Hi, students. Welcome to video 18 on fossil fuels. So first, we're going to talk about coal. Coal is the most abundant fossil fuel. The United States has a lot of it, 28% of the world's reserves. Most of the coal that we burn, we are using for electricity, and this is where we get most of the world's electricity. So if you look at the top three coal-burning countries, you see China, India, and the United States. So China overwhelmingly burns the most amount of coal. However, we're going to talk about how that's a little bit misleading also. So here's the coal deposits in the United States. This right here is what we consider to be coal country, where lots and lots of coal mining jobs are created. You also have all of your factories here. So lots of pollution on this side of the United States instead of being over here. The wind also blows this way, which will cause the pollution to come towards us. So here's the trends over the last 30 years. You'll notice mostly that Asia has been increasing, so that includes China. So everywhere else has kind of stayed, stagnant. North America has actually gone down a little bit, but overall, worldwide, we have had still increasing amounts of coal being burned. So here is the consumption per capita. So this is kind of the interesting thing, and the thing we need to think about when we're looking at, how much is China burning, how much is the U.S. burning. So these numbers down here, you'll remember that China was number one, then India, and then the United States. Even though India was burning a higher total than the United States, you'll notice that the U.S. burns way more per capita, meaning per person. And then China, even though it had a whole lot more than the United States, still is almost equal to the United States. So it's really important that we look at the per capita coal consumption, looking at the amount of people in the country and how much you're burning versus just the total amounts that we're burning. So here's our types of coal, moving from less coal to more coal. Peat, which is not really a type of coal, but it's the first thing that has to form, is basically just decayed plant material. You can burn it, but you're not going to get a whole lot of heat out of that. Lignite is moving more towards what is actually considered to be coal. It still has a low heat content and a low sulfur content, meaning it doesn't have as much pollution. Bituminous coal is going to have a lot more heat. Excuse me. But it still has a lot of sulfur. Unfortunately, this is the majority of what we burn because it is the most plentiful. Anthracite is not very common, but it has the highest heat capacity. So if you're actually burning this, that's the best to burn. It also has a lower sulfur content, which is better. So when we talk about clean coal, you may have heard this before. In 2008, the Americans for Balanced Energy Choices came out with this kind of idea about clean coal, and they ran, a $30 million campaign budget about clean coal. But if you break it down and you actually look at who the Americans for Balanced Energy Choices are, they are all of the coal companies. So basically, they decided to start saying this clean coal thing was real, when in reality, there is no such thing as clean coal. When you burn coal, no matter what it is, you're going to have pollution. You're going to have particulate matter. You're going to have CO2 emissions. So they also sponsored the CNN Democratic presidential debate in 2008. And ironically enough, or maybe not, there were no climate change questions that were asked at all to the candidates. So coal companies were funding this, so they don't want to talk about climate change because this is one of the biggest drivers of climate change. So again, just note there's no such thing as clean coal. Looking at environmental impacts, the obtaining impacts are going to be anything related to the mining of the coal, so deforestation, mountaintop removal. If we're exploding things on top of the mountain, we're using fossil fuels to make the explosives. Coal dust is going to be what contributes to the black lung disease that we've talked about a lot now. When I actually am using the coal, I'm contributing to air pollution from things like sulfur and nitrogen oxides. I'm causing thermal pollution into the environment because I'm heating up the factory, and that in turn is going to heat up the environment around it. And I can have acid rain. After the use, so I'm going to be contributing to climate change because those greenhouse gases that are being released are trapping heat at Earth's surface. Acid mine drainage is also what can happen if you abandon a mine and it's not properly closed. And we saw that we can have coal fires and we can have lots of coal ash left over after that we have to deal with. So looking at oil is petroleum. So this is a picture of what it looks like when it actually comes out of the ground, not at all what it looks like when it goes into your car. So this is the liquid version where coal is the solid. And we're going to separate this liquid because it's not very usable to us right now into different components. And we're going to be able to make gas, oil, diesel oil, asphalt out of this material. So here's how we do that by a process of fractional distillation. Basically, I put the crude oil in and I boil it. And some things can be boiled pretty quickly and others have to be boiled a lot hotter. So things that are going to come off really fast are going to be things like petroleum gas, gasoline that we put in our car, aviation fuel. Things that are going to take a lot longer are going to be things like asphalt. If you can imagine, asphalt is going to be really, really kind of a chunky, blackish material. And so that's going to be what's kind of left over after all these other fuels have already boiled off. So these things require a lot more heat. And you'll see here's the fractional distillation containers and what they actually look like in real oil factories. So how do I get this stuff? You have to drill down into the ground. We find what we call anticlines, these things that make this A shape right here. And the oil gets trapped between the rocks here. It can't go through. And so it kind of sits at the top of these anticlines. You'll notice that there's gas coming off of the oil, and that's where we get natural gas from. So I can drill a well, I can hit the oil, and it's going to come up by gravity. Sometimes I have to shoot water and gas down inside to make the oil come up if there's not enough of a difference in gravity there. Once I have the material, I'm going to transport it to a refinery. And that's where I can do the fractional distillation process and I can get out things like what I would put in my car or the airplane or tar. So in terms of who's producing it and who has the oil, our top producers, maybe just know the top three. The U.S. is the number one, which might be surprising. You may think that most OPEC countries are going to be up there. Saudi Arabia has the next amount, and then Russia is producing the third highest. Here in the United States, we are consuming the most, so we are producing and consuming the most. Then you have Saudi Arabia, and then you have Russia. And in the United States, we mainly, and also in the world, we mainly are using oil for transportation. So most of that oil is for driving our cars, driving, trains, planes, any of those kinds of things. So sometimes it's not as simple as just getting a liquid. Sometimes it's more of, a liquid incorporated in a bunch of things. So there's also something called tar sands. Basically, it's sand that has oil embedded in it. And if you can squeeze it out, you get that material and you can actually use it like regular oil. So Canada has the majority of these tar sands. 70% of our known reserves globally are located in Canada. And this is a main site for getting these tar sands. This is Alberta in Canada. And basically what we did is we have completely scraped off, we have completely taken away all of these habitat areas, and now you see that environmentally, you can imagine there's some problems going on here. Number one, it doesn't look as good. It's not going to be a place for tourism or recreation anymore. We've gotten rid of all the trees, so that soaks in carbon dioxide. But you're going to have a lot of erosion problems here and a lot of water pollution from these sites. So some materials that we get from oil are called petrochemicals. So anything that is basically a derivative of petroleum. Paints, makeup, carpets, a lot of fibers that we use for furniture and things like that. Fertilizers are made from petroleum products, plastics, tires, any type of rubber. All of this stuff is a petrochemical. So if it's not a natural fiber from like a plant or something like that, it's probably made with oil. So, how long will we have oil for? There was this hypothesis back in about the 50s or 60s that we would actually reach peak oil around 1970. This is called the Hubbert curve. And then we would go down as we would have depletion of that resource. What that didn't take into account is the new technology that we have that can get at oil that we used not to be able to get. So we did have some peak in the 70s, but then we kind of went down, and now we've come back up again. So we have a lot of oil. Probably for the next 100 or 200 years, we will not run out of this material. The problem is we're trying to transition because we know that there's lots of issues that go around along with producing high amounts of carbon dioxide. So the last thing we're talking about is natural gas. Natural gas is the gas form of hydrocarbons. So we had the solid coal, the liquid oil, and now we have gas. In terms of who has it, these are the top three producers of natural gas. The United States is the number one currently. Then you have Russia and you have the Middle East, which is about equal. In terms of who's using it, again, the United States is the top user. Then you have Russia and you have China. Worldwide, we are increasing our use of natural gas. This is replacing coal in some places and oil in others. So that's a good thing because natural gas tends to be a little bit cleaner. So we do call it the clean fossil fuel. It doesn't mean that it's completely emission free, but most of this fossil fuel is going to be methane, depending on the different types of fuel, it's 50 to 90% methane. That means there's not as much CO2. So conventional natural gas is dug down just like this with a drill, and you drill vertically and you get it and it comes out. Very similar to oil drilling. Unconventional natural gas is kind of more of what we think about with fracking with that term. So you drill down and then you drill horizontal as well. So this would be areas where we haven't actually been able to recover yet because it does require this horizontal drilling. And you'll notice that the rock is broken up. That would be because of the fracking. We're pushing down liquids into that. Unconventional is horizontal drilling. It's also coal bed methane areas. So coal also gives off natural gas, and so we can get our materials from that way. Here in the United States, or here in North Carolina, we do have a couple places where we are planning to do fracking. So these are some of the areas where fracking might be possible. And then here's a pipeline now that is going through North Carolina that is going to be permitting natural gas to flow through the state. So this was in 2018, kind of when they officially granted permission for this pipeline to happen, but there's some others around the state as well. And most of this is coming from Virginia and other states, and it's going to be coming down into North Carolina. So in terms of looking at years of fossil fuels, we kind of talked a little bit about oil, 50 to 100 years maybe. We have the most amount of coal left, we think, in terms of years, but there's a lot of research going into trying to eliminate these things because they do cause such a carbon footprint, and they are causing our temperatures for the globe to rise. So that's it. Bring your questions tomorrow to class.